Good morning, good afternoon, everybody. This is your Friday HSM Hangout. My name is Jordan Roberts, Product Specialist for the HSM platform at Autodesk. I'm very excited today because we've got Wayne Griffenberg on the line. We're going to be covering our new updates to our 4-axis rotary. We're going to be doing it inside of Inventor HSM. Just so you guys know, we're going to be covering a lot of information, so stay tuned. And before we get started, just a couple of quick housekeeping items here. I want to understand what kind of machinery everybody's using. We ask these same questions every week. It really helps us content to cater our content to our customer base. So great, thanks for voting, everybody. The votes are coming in quickly. And Wayne, any guesses here as to who's going to win the competition today?
Oh, I have a feeling it's Haas.
Let's take a look. Look at that. Haas is the leader, 55%, but they're not alone. So guys, this is live. This is interactive. In the chat, please feel free to shout out your companies, your Instagram handles, also any machinery you might be using, whatever you want to share, feel free. Also, if you have any questions as we're going over the information, please let us know. We've got application engineers standing by as well as Wayne to help out. I want to understand how long everybody's been exposed to the HSM platform. Now, just to level set, you can access this technology in 3 flavors. You've got Inventor HSM. It's a really, really great tool to use with your integrated CAD CAM. You've got HSM Works for the SolidWorks customers. And then we also have a cloud-based product called Fusion, which is really disruptive and also allows our customers to use the HSM platform. So great. Thanks for voting, everybody. So Wayne, today our crowd is distributed here. We've got the majority, the overwhelming majority has been on board for over 6 months. So I'm sure they'll be very happy to see these updates that we're going to share with everybody.
Yeah, I think it's exciting, especially with the 4th axis wrap coming into HSM. I think it's exciting for everybody.
And now we should probably see a high level of people here selecting the HSM platform based on our last result. But get your votes in. Really curious to understand if anyone's using any other CAM platforms today. That's certainly okay. Let us know what they are in the chat windows. And look at that, just overwhelming majority here on the HSM platform. So that's really great. Thanks so much for voting, everybody. We do appreciate that. So Wayne, I want to jump into that PowerPoint deck. You've had a crazy week. You've been all over the country helping out manufacturers improve their workflows. Give us a little overview as to what we're going to cover today.
Thanks, Jordan. Today we're going to look at our overview for rotary axis. I'm going to step through, let me change this slide, there we go. So we're going to take a look at in Inventor. Today we're going to draw up a real quick part, set up and orient it for rotary axis machining, apply some indexing toolpaths to show you how to get that indexing code out as you're working through different planes on your model and different features. We're going to apply some of those new rotary wrap toolpaths that are inside Inventor HSM. We're going to show you how to pattern those toolpaths around the part. Post-process, get some code out so I can show you how it's rotating around the part. And then we're going to make a design change and see how it's completely integrated inside of our CAD and our CAM. Okay, so we're going to walk through that easy-to-use interface. This is the part we're going to look at. It's a torsion adapter for a vacuum cleaner, and draw it up from scratch. And then we're going to put some toolpaths on it. Put some rotary axis, put some drills on there, and then do some of the new wrap toolpaths. So let's get started. So we're starting from scratch today, so I'm going to walk through, I'm going to create a brand new project to start working with. So this is the Inventor project that I usually work with when we do a lot of our demos and we do training. I'm going to go in and create a brand new project from scratch, so I'm going to go to Projects, New. It's a single user project, but if you have other users that you're working with, you can make a Vault project as well using our Vault. So I'm going to give it a project name. We're going to call it our 4-axis rotary. And then I'm going to point to a folder on my computer where I want data to go and stay in that folder. On my desktop, I created one called 4th axis rotary. We'll open that up, and that's where it's going to save the parts. Okay, I'm going to go to Finish. Now I have a new project to work on. I'm done. And now in my new project, I have no files yet, so we're going to start from scratch, a brand new file. So I'm going to go to New. We're going to start a new standard part and create it. And so I like to work on the plane that's normal to the Z. So I'm going to start my rotary part going around the x-axis. That's going to be my a-axis rotation. So I'm going to draw in the XY plane today. In Inventor, it's the front view. We work in CAM, it's the top where our Z is, but in Inventor and a lot of the CAD software, the front view is where the Z comes out. So I'm going to work in the XY plane. I'm going to expand down the origin. This is a good way to find your planes. Not the only way. You can turn these on and keep it default, but I like to work with it from scratch. So I'm going to use the XY plane. If I right-click, I can say New Sketch from here, or I can just simply select the plane and select a new sketch right from here, right from the graphics view. And it brings us into that sketch view on the front, and these are our sketch tools on the ribbon bar. So what I want to do, and often I do this, and it's an interesting thing that it's not automatic in Inventor, but I'd like to have a point at the center, right here at the origin, that I can use for my basis for my sketch. So what I often do is I come in here, I'll choose center point, and project geometry. And I know you can set up a template where you can have this open in that template where it has those center point in the plane set up for you. But if you're starting from scratch, you can do it this way. Just simply project that center point. And now I can use that center point to drive my, my design. So I'm going to go in and make a simple rectangle. Start at that point. If you notice as I hovered over, it turned green, so I can snap and I can start to stretch a rectangle in any of these quadrants. So I'm going to work in this quadrant because I want this to be my front of my Z, or shall I say where my Z and my X meet. And I want to rotate that around the X. So I'm going to start in this quadrant. I'm going to make a simple rectangle. We'll make it 4 inches. I'm going to hit Tab, and we'll make it 2 inches, and hit Tab, and Enter. And now I have a simple rectangle. One thing I want to show you, what I want to do is I want to make these become construction lines. Now you can select them. You can hold Control and escape out so I don't continue the rectangle, so I hit escape. So you can select each of these lines individually and then select and make them construction. One thing I'd like to show you, especially in the Autodesk world, and this is the same in Fusion, if you start a box, if you click and do a left click and start to stretch a box, if you go from the left to the right, you get this red box, and it's only going to select what's inside the box. In this case, only my origin was inside the box there. If you start a box going from the right to the left, you get this green box with the blue dots on it. And this is going to select anything the box touches. So going from left to right is anything that's inside the box. Right to left is anything the box touches. So it's a simple way to select, but I think a lot of people aren't aware of that. And you can also work with that the same way in Fusion. So if I want to select all these lines, I just start a box up here, left to right, select everything in the box. Yes.
Apologize to interrupt you, but a couple people mentioning it'd be helpful if you weren't full screen on Inventor.
Oh, yeah, absolutely. Thanks, Al.
Yeah, no problem.
There we go. Sometimes I leave it in because down here I like to show off in this corner, and sometimes I get feedback that people can't see that corner down there as we're working through some of the functions. But that's okay. If we expand, we can see a lot of that graphics view. I can even stretch this back a little bit so we can see a little bit bigger. Okay, so I'm going to start a box going from left to right. I'm going to select all those lines at the same time. I'm going to change them into construction lines. Now this is going to be the basis for the profile of my rotation, of my rotary part. In this case, it's going to be like a tube part. So I'm going to choose another rectangle. I'm going to start in this corner where it snaps and it turns green. And I'm going to have it snap. And if I hover over that line, you notice the constraint. It recognizes when that line is connecting to the dotted line or the construction line. So all I have to do is now define the thickness of the wall of my tube, because I'm going to rotate this around the X. So I'm going to choose a dimension, and I want this to be 3/8. So now I'm set up to rotate this part or wrap it around the X and have it as a revolve. So I'm going to finish that sketch. Now I want to revolve that profile, so I'm going to go up to revolve. It recognizes the profile. All I have to do is select the axis of rotation. So now I have a revolved part. It's a tube that I'm looking for, the shape of the design, and it's also around that x-axis. So I'm designing the part that it is going to work when I go to bring it in and be able to revolve it around that a-axis. So inherent in my design, I'm setting it up so it'll work well when I go to do my toolpath and I go to work on it in CAM. Okay, so I'm going to have some features on here. This is the front of the part, and later on I'm going to consider it the top. So I want some features on that front plane, which is my XY plane. But I also want to put features where it intersects with the front and back of the part. So I'm going to add some offset planes. So I'm going to go to plane, offset. I'm going to offset from this plane 2 inches. And offset a plane in the front that I can put some features on. I'm going to do the same thing. I'm going to select that same plane. I'm going to offset from that plane, and I'm going to go a -2 inches. So now I have some planes that I can work 2D geometry, which I can now project, or I'm going to emboss them, if you will, and engrave them onto the side of the part. So we don't need to see them right now. I can always select them later. So I'm going to highlight them while holding Control, right-click, and hit Visibility. So now I can hide them so they don't get in the way of what I'm working on. All right, so I am going to do a sketch on that front plane, so I'm just going to simply select the work plane and then select New Sketch. I'm going to go into the front plane here, and I'm going to just simply put a rectangle in here. I'm going to go and draw a rectangle. I'm going to start it from scratch. I'm not even going to put any dimensions. You can add dimensions here. I just want to show you can do this. If I just put a rectangle in space here, and I can move it and stretch it, and I can add other constraints onto that rectangle. All right, so I'm going to add some fillets around here. So let's go and add some fillets. Right in the corner, I'm going to say we'll put a 1/4 inch fillet in that corner. So if I hover over the corner, I get a preview of what that fillet will look like. All I have to do is click the corner, and I get those fillets on there. Okay, so now I'm going to add some dimensions after the fact. So I'm going to add this. I want this to be 2 inches. Okay, and I want this to be the width. I'll make this 2.5 inches. And what I didn't do is I didn't project my point in here. So I could do that right now. So I'm going to go to the center point, project it in, and now I can measure from that center point. The reason I'm doing this, I can also project any of this profile geometry, but often when I work, I like to add features that I can turn off and on later on when I'm doing CAM or if I'm doing other operations. And if you add a profile or if you go to project those features in, they're now linked. So if you turn off something in the past, it'll turn off another feature in the future that depends upon it. So I like to work independently. So I want this dimension to be from the center point or the origin. So I'm going to put another dimension from this origin to that line there. And I'm going to make that 1.25 inches, or 1 1/8 inches. Let's make it 1.25 inches. Okay, so now we're constrained, except now I have a dimension, or shall I say, I can move this thing up and down in this plane. Now what I want to do is I'm going to add a construction line down the center. And I'm going to show you we can add some symmetry. I'll just make that 4 inches. And now I want that to be symmetric about the center line. So I'm going to add, I already added that center line. I'm going to make that become construction geometry. And now I want to add symmetry. So I click symmetry, and down here in the corner it says select the first sketch element. We'll choose the top line there. Then it says check this, or select the second element. And now it says select the symmetry line, which is that center line. And now I have a symmetric constraint. So as I change this, I'll make it 1 inch. You'll see it'll stretch from the center out. So that's a way to add constraints as you're working on your design. Okay, so now I want to get this projected, not as a cut through. I don't want to cut it through. I want it to wrap into the cylinder. I want to cut through as a wrap around the cylinder. Now, there's no direct project for wrap, but what I do is this. I go to Emboss. And this is the Emboss tool. You can use this to engrave too. It can be text in different shapes and different types of geometry. In this case, it's just this box, this pocket. So I chose to engrave it. I can give it a depth, and I know my wall through is 3/8, so I'm going to go 0.375. And I can tell it right here, wrap to face. So now we can wrap that geometry right to that face. It projected through because it's looking at the direction I want that to wrap. So it's looking at the direction to cut through. I just simply flip the direction, and now I'm cutting it and wrapping it through the part as if I'm going to engrave it. Say OK, and now we have a pocket through the part that's wrapped around that cylinder. So now I would like to have 5 of those go around the cylinder, so I'm going to highlight the Emboss feature that I just created. Go up here and select Circular Pattern. Let me bring it over. So I'm going to do a circular pattern around. So it wants to know what's my center rotation axis. I can just simply select one of these cylinders. I'm going to select the central one. And I want to make 5 of them. So now I'm going to wrap 5 of those pockets around the part. I'm going to say OK. And now I have those pockets wrapped around. Okay, so now I want to add some hole features that are going to be on the back side, because the front side is the center of the pocket. The back side is going to be this rim right here. I'm going to put some hole features on there. So I'm going to flip it around. My Z is going the other way. I'm going to use this work plane 2 that I created to put some holes here. So I'm going to edit on that work plane sketch. And I'm just going to put a line across here, and I want to put some points going across that line. So what I want to do is I'm going to create a line. I forgot to project my center point. There we go. I'm going to create a line. We'll make that 4 too. Now, I want to be able to have that line, a point on this line. It doesn't matter if this is construction or not. I'm just going to put a point in that line in space. Okay, now if I drag that line, or that point, it stays along that line. Now I'm going to add a dimension to it, because I'm going to make a pattern of 5 of these. There we go. I made an 1/8 of an inch, or an inch and an inch and a quarter. And now I'm going to add a pattern of 5 of those points. And those are going to be the center points for my holes. So I'm going to go up to do pattern. That's circular. I'm going to change this to a rectangular pattern. Come here. And I'm going to select that point, choose the direction I want it to go. I'm going to select this direction, and I want to make 5 of them. So I select 5 and then give it a distance. I'm going to say, you can even do this. You could say 5/8. So you can even use fractions in here, and it works out nicely. So now I have 5 holes. I'm going to select OK. At least 5 positions for those holes where I want them to go. Finish that sketch. Now I'm going to highlight the sketch. I'm going to go up to add a hole. And it recognizes those points on the sketch as places where I want to put holes. These are 1/4 inch. I don't have to change that. I want them to be 1/4 inch holes, but I don't want them to go all the way through. I want them to be a 1/4 inch deep. Now you can add threads. You can add a tapped hole. You can add other features to it. It's going to put the drill point in, but these holes don't have any taps, so I'm going to leave them the way they are. And now I have a set of holes. So all I did was create a sketch on that plane that's adjacent to the face of the part, and I added points and just selected hole. Again, I can pattern those around. So if I select the hole, go up to circular pattern, it wants to know what's the center of my axis of revolution. And I'm going to choose 5, and now I have those holes in that plane, each of those planes. So later on, we're going to index around to drill those holes. I have one more feature, these little fingers, or these slots that are in here. So I'm going to select my work plane. We can work off my work plane too. And I'm going to create a sketch on that work plane too. And I'm going to create a slot right here. I'm going to go in and project in my center point, create a slot. And it's okay, I'm going to make it a 1/2 inch slot. And my diameter is going to be, my slot hole is going to be a 1/2 inch. Okay, so it's okay if it hangs off because it's going to be an open slot. And this is one quick way to be able to get that feature. Again, the same way we did it before, I'm going to emboss it. We want to do the engrave. If you remember the last depth that we used, if I change the projection, it'll project to the other side. I'm going to wrap it to this face and then say OK. And now I have that wrapped slot feature. going to add a radius on the corner here and go into my fillet, grab this edge, and I'm going to grab this edge, and we'll make it a 1/4 inch. And now I want to be able to make a pattern of those features that go around. There's 8 of them. So I'm going to grab and hold Control, get the fillet and the emboss, make a pattern going around that feature. It wants to know what's the rotation axis because it's highlighted blue. The next thing is, how many do I want? 8. Okay, and now I have those features, those finger features. So that's the part we're going to make. We're going to set it up to be able to make this on the machine, on our rotary axis table or A-axis table. And I'm going to save it before we do, so I'm going to go up to Save. It knows the project because we set up the project. It knows where to save the file. And I'm just going to call this one my, this is my torsion adapter. Save it.
I'm just going to jump in for a minute here, Wayne, and say, you know, this is the first webinar, I think, where we've gone through how to model a part. I'm seeing some great feedback from users that they like watching you do that. And I think it's great. A lot of the times we think of CAM as just the toolpath, but a big part of CAM is, in fact, creating the geometry of what you're going to do and creating the fixtures for what you're going to do. So I think we'd love to hear feedback. Did you like this? Should we do this on more webinars? And then also just a little plug for some of the videos Lars has been doing. He's got a bunch of great videos on how you can leverage the assembly environment for modeling your fixtures and getting a good idea for how things are going to lay out on your machine. So just a little plug, if you're enjoying the CAD side of things, take a check at Lars's stuff. There was one comment, why did you revolve versus extrude? Both options work, but some great tips through that. Wayne, good job.
Thanks. Yeah, I highly recommend Lars's videos. He does a great job putting together how to work with the parts, bringing them into Fusion, and putting CAM on. So he's a really good resource to check out. And use.
I'm seeing lots of comments here that people enjoyed watching how you've worked through the modeling process. So I think we should keep that up in the future.
Awesome, will do. Especially when it comes to these new toolpaths that we're seeing from our development team, who are able to now get some awesome stuff. Awesome algorithms working with wrapped toolpaths. So I think the question will come up a lot more as to how to make geometry that's wrapped around a cylinder like this so we can get those toolpaths on. So that's mainly why we're walking through this process.
I have to be careful, but I'm talking to the right audience now. I often say you can be a CAD guy without being a CAM guy, or a CAD operator without being a CAM operator, but it's pretty impossible to be a CAM person without having a strong understanding of the CAD application. So glad to see that there's more people wanting more of these tips. And again, sorry for the interruption, but I thought it was a good thing to bring.
No, thanks, Al. I totally agree. Awesome. Okay, so let's set up now. We're done with the CAD part of it, and let's go into the CAMs to be able to get some toolpaths on this part. So I'm going to go switch over because we're using Inventor HSM. It's the plugin for Inventor. When we switch over to the CAM tab, we get the ribbon. Oops. We get a ribbon bar that has the CAM toolpaths and the setup and all the things we need to be able to work with CAM. We're also going to see on here when I start to do a setup, the browser is going to change to show us some CAM features in the history. So that's the first thing I want to do. And the important step, especially when you're setting up for a rotary axis, is to do your setup the right way. So the first thing I'm going to do is click up here is my setup. You have that in-context help when you need it. The manual's there whenever you need it. So I select Setup. I'm going to stretch this over a little bit. I'm going to lose a little bit on the graphics, but I'm going to be able to see more of those tools over here. So initially I select Setup, and it recognizes on mine that I want to either do turning or mill turn or milling. In this case I'm going to do milling, but you can do both in this interface. So you can work the same exact workflow as you're working in milling, you can do in turning as well. So in this case we're going to switch it to milling. It recognized the Z is up and my X direction, and that's the direction we want to rotate around. It's not often going to be that case, but we set up this part and drew it in such a way that that will happen. But that's the idea, to always have your part, if you're going to do rotary axis around the A axis, make sure the X axis is the center of the cylindrical shape of your part. So the first thing now I want to go into my stock and set it up as a cylindrical tube. So I can go into relative size, down here a relative or fixed size tube. I'm going to use relative size tube, and it recognizes almost, as soon as I choose the center axis, it'll recognize the boundary of the inside and the outside ID, or the OD and the ID. So I can add some radial offset. In this case, I'm going to leave it at 0. For this webinar, we're going to leave it at that shape. But normally, I would like to leave some on the back here, so you can do a backside offset. Let's say we even do that, say 1/2 inch, so we can hold it into our chuck there. I probably would add 1 inch. But that's just to show you can do this in this interface. So my setup is looking pretty good. My Z is pointing up sort of in the middle of that pocket right there. And I can show you, I can reorient that Z. Let's say we want to set this part up in a way where our Z is going to be pointing up normal to those holes. So the first thing I want to do is drill those holes in the Z so I have 0 rotation. What I can do is I can select my Z axis. You can do it this way, or you can simply select the shaft of the Z and then select a feature like that hole. It'll flip it. It recognizes the hole vector and flipped it over. What we need to do is just flip Z axis like this. And now we're aligned with the center of that hole. That's one way you can align it with a feature of your model to have it aligned the way you set it up in the machine. Okay, so if you're going to rotate it this way, just make sure you select Z-axis rotating. Your plane is going around the X-axis because you don't want to rotate around the Y because that'll flip your part this way. Okay, so now we have the axis the way I like it. The Z is pointing up towards that hole. Those are the first holes I'm going to do. So I'm set up the way I'd like to see it in the machine. I'm going to say OK. So there's our setup. Now we're ready to do some toolpaths. So the first thing I want to do is I want to drill these holes on top. So I'm going to go up to the drill toolpath. And I forget what the size of that hole is, so if I hover over, I have a short-term memory here. But if I hover over, you see down here in the corner, it'll give us feedback over whatever hole it is that we're hovered over. Even arcs that are in the same plane, you can see those as well. So this is a 1/4 inch, so I'm going to select the 1/4 inch tool out of my library. In this case, it's a brand new part. I have some libraries that I set up, and I highly recommend setting up a tool library that matches either your machine, what you have in your pockets, or in your tool crib. In this case, I have a bunch of aluminum tools. I have some steel tools in the library. It's easy. Just right-click, create a new library, and you can start creating new tools, or you can copy them from our sample library. The sample library comes with a lot of good tools to get started with. In this case, I'm cutting aluminum. I'm going to choose aluminum. I don't know if I have a 1/4 inch drill, and that's okay. If I don't have one set up, I can set one up. I'm just going to simply search by type. I'm going to search by drill, and I'm going to filter on the diameter, which is a 1/4 inch. And now it filters on tools in my various libraries that I can choose and work with. Let's select this 1/4 inch drill right here. Brings in the feeds and speeds of that drill. Wow. And so the next step is to select my geometry. And now I want to select the hole faces. That's the first thing that's lit up blue here. So I'm going to select this hole face. Because it's in the same plane as my Z, I don't have to choose any rotation. And we'll talk about that in a minute. So I'm in that plane, so I'm going to be able to select the same diameter of any holes that are in the same plane. But notice it didn't select the diameter of any of these other holes because they're not in that same plane right now, X, Y, with the Z up.
So Wayne, can I jump in for a second here? There's a bit of a question in regards to work offset setting versus the tool orientation. I'm going to answer the question at a high level. If I get it wrong, Roger's asking the question, just go ahead and clarify. So the work offset setting in the setup is defining where Z is going to be pointing, what the orientation is when you set up your machine, when you initially set your work coordinate system. Tool orientation is used when you want to program the machine to rotate to a different orientation. So we use tool orientation to program the machine, to reorientate the machine. It's what we call 3+2 programming, reposition that axis. But the WCS is set up to define the initial orientation. Just as an aside, if there's new users, some people end up caught in this trap where what's a strength of the software ends up being a weakness, and that is if you create a toolpath without any setup yet, we're automatically going to create the setup and pick what we think is the correct direction for what direction Z goes in, and then we found some new users are then using tool orientation to rotate the Z. So as a reminder, the setup is defining how the machine is set up. The tool orientation is programming the machine to rotate from that initial setup to a new orientation. We're looking to update some of the documentation to help people with that, but I don't know if that was the question. I think now is a good time to bring that up. So again, the work offset in the setup is going to define how that setup is set up when you initially put the part in your machine. Sometimes it's going to be wrong if you create a tool path and we automatically create your setup for you. Tool orientation is used to program a fourth or fifth axis to rotate the machine to that new orientation. Hopefully that helps your question, Roger. If there's more to it, feel free to ask the question. Sorry to distract you in the middle of your flow there, Wayne, but it felt like a good time to answer that question.
No problem, Al. That's actually a really good point. I often like to think of it this way. As Al had mentioned, this setup is really matching the way it is initially set up in your machine. So if the Z is up, the X and the Y are set in this position, that's the way it's sitting in the machine. I often like to think of it this way. If I'm going to manually take this out of the machine, rotate it, and put it back in, then I would do a new setup with that new orientation. So that's a manual operation of reorienting your part, taking it out, put it back in. You would use a new setup because then it won't give you any rotation. It's going to be a new WCS, if you will. When you're in one setup and you do a drill setup like this, and we're going to do this in a second, I'll show you. If I want it to rotate, if I want rotation call when I post, I want to do it in the same setup. That's when I'm going to use tool orientation because I'm going to reorient the part to the tool to get that rotary call so that it knows that I'm doing drills on these holes. Then I'm going to rotate it again. So I'm not doing that manually. I'm having the machine do it, and I would do it in one setup. But the initial setup, as Al had mentioned, is the way it's initially set up in the machine. And then we're going to now put toolpaths, which will now manipulate it as the machine's running. So in this case, we have this drill set up. Let me go back in. I'll show you. I selected that geometry, just a few more steps. The heights are going to leave out of the box, but they have different cycles that you can run. Drilling, I'm going to leave this as regular drilling, but you have chip breaking, counter boring, tapping cycles that you can run, boring cycles. I'm going to leave it at drilling, but I just want to show you in the cycle tab, that's where you can set that. Now, I won't have any rotation. I won't have any rotation out of here when we post out the code. And we can take a look at that in a minute, but I won't. It's just going to stay on the Z top, and it's going to come in and drill those. Now, what I want to do is I want my rotary table, my machine to rotate it around to have those tools or those holes now presented to the tool. Now, I'm not going to physically move it. I want it rotated in the machine. So that's where I would do it here. I'm going to add a new drill cycle. Notice it's still oriented from that last initial orientation. So if I go into my geometry, now I want to do tool orientation. Now I'm going to change that Z. See, it's highlighted Z. I'm going to rotate that Z. In other words, I'm going to rotate the part around. Oops, there we go. To be normal to this hole. It flips the Z because it sees the vector going this way, so I just simply need to go over here and flip Z axis. Now I have this Z normal to that hole. This is where tool orientation comes in because that's going to give you a rotary call to move to this position. So I don't have to do a new setup at all. So now in the same case, now we're in the same plane, I can choose select the same diameter. And now it should grab. Oh, I'm sorry. I only selected that as my plane. I didn't select the hole yet. So I'm going to select the hole faces, this hole, and then it applied select the same diameter. So I'm going to hit OK. Excuse me. And you'll see on this drill tool path, we're oriented like this. And on this tool path, it's going to rotate around in my rotary around the X, or around the A, and it's going to give us this tool path. So we can do this in setup. If I highlight setup, I'm going to simulate, and it'll show us the tool moving, and it won't have the part rotate around, but it'll show us the tool where we're drilling those holes. rotates around, and we're going to drill these holes now. That's how we get indexing, by using that tool orientation in the toolpath. So if I post out this code, I'm going to go up to setup, and we'll post real quick just to show you. I'm going to use the Haas with A-axis, works well with the rotary table. Post out that code, overwrite what I had before, and now we have the lock codes, 0 rotation. It's going to offset, it's going to come down and do this G81, run that cycle on those holes. Then down here we see on drill 2, it unlocks, rotates A72 degrees, locks again, and it does the drill cycle on those additional holes. And then down here it returns back home to A0. So we get rotary code that we can send to the machine to rotate that drill cycle around.
Maybe just a quick introduction or point. You may bring up post later. There is a requirement for some post customization. Some posts have more flexibility than others. A lot of people said they had Haas. We have a default Haas A-axis post. That does assume that the A-axis is on the right-hand side of the table. If your A-axis is on the left-hand side of the table, you need to rotate negatively around the X-axis. So just keep in mind it does take some post customization. I think some people said they're using Tormach. There was actually an update recently to the Tormach post. It does support you defining the axis and the direction within the configuration of the post. So just keep that in mind. If there's any questions, the forum is a great place to go get answers. I see Seth, who's on the webinar today. You might even get an answer from him, one of our users, or some of our guys. But keep in mind to leverage a fourth axis probably would take a little bit of post customization just to define where your axis is set up.
Awesome. Thanks, Al. Excuse me. So then you would think, well, if I have to get these additional holes, I have to do this process over and over again. And we don't really, because we can do a pattern now. So I'm going to take these drills. I just want to show you that we can get rotation this way, but now I'm going to do a pattern around the part to get rotation. So I'm going to delete this second the second set I did right here. I'm going to take these drills. While I highlight it, I'm going to go up into pattern. Okay, I'm going to do, instead of a linear pattern, I'm going to do a circular pattern. It wants to know the axis of rotation. I'm going to select that inside face, that inside rotary face. And I'm going to do it 5 times. So you can see I can plug in that number according to the number of holes or hole positions I have there. And you can also do order by tool. Later on, we're going to look at other toolpaths we can put in here where we do a tool change. You can have it order by tool so it does all that tool first before it rotates. Or you can do it order by operation. So then you can have all those operations done with the tool changes before it rotates around. So in this case, I'll just leave it on order by tool. Select OK, and now we have this circular pattern. It's going to work its way and call up the rotation for each of those positions to index around. Let me get back up to Z. And again, we can look at this pattern and post out that code. I'm going to do it really quick. As Al had mentioned, this is the one post. Oops, I didn't hit post. The Haas A-axis. And we'll see it'll update and it'll give us each of those positions of rotation here. Okay, so that's indexing. You can, of course, do the indexing and patterning with toolpaths. You can do this with all of our adaptive, pocket, and contour. Before I go in to do those, let's actually do it. Let's go through, and I want to show you what has been added into our HSM. It's in Fusion as well. That you can go into our adaptive, our 2D pocket and 2D contour, and you can do a wrapped toolpath. So I'm going to start off with this pocket right in here. And I'm going to do a wrapped toolpath inside that pocket. So I'm going to do a 2D adaptive. Okay, working from left to right, that same easy to use workflow. Select the tool. I'm going to select out of my library, my aluminum. I'll grab my 1/4 inch flat end mill. I'll probably do something bigger, but I'm going to do the 1/4 inch for this webinar. And now I'm going to go into geometry. Now there's a function down here, wrap toolpath, and I just want to show you, I'm going to select this pocket edge right here, right down here. And when I do, it wants to project it into the XY plane. It's not really wrapping anything there until I turn on wrap toolpath, and now you'll see it'll project. Right now it's got a red line, dotted line, because it doesn't know the cylinder we want to wrap around, or at least the radius of it. So that's what I want to select. I'll select this outside face, and now we have, and you can see the geometry is now wrapped, where it's selected that area that's wrapped. And now we can apply the 2D adaptive in the same way we do if we're working on a flat plane. It'll work the same way now on a wrapped geometry. I'm going to leave these things out of the box for now. I'm going to say OK, unwraps it, and then rewraps it around that geometry. So now we have...
Did I jump in?
Yeah, please go ahead.
Just a second. Maybe go back into that toolpath. I'd like to explain something. It's a difficult concept to understand for some, but I think it's worth mentioning.
Sure.
There's a few things that happen when we set the wrap plane. It's set the center axis, but you're also going to see a wrap radius and an offset for the wrap radius. What I'd like to point out is selecting that wrap plane is also defining where that chain is going to be, the tool is going to be accurately following the chain. The reason for this, I don't want to get too deep, but in order to properly create wrap geometry, you need to actually know the tool diameter when you create it, which generally you don't when you're doing your CAD work. So some part of the tool is going to gouge just because the edge of that side wall needs to be parallel to the center axis of the tool, but offset by the radius. Again, it's probably hard for me just to describe. So basically what I'm saying is that it's going to gouge the geometry that you've selected somewhere unless you modeled the part perfectly. And this wrap radius or wrap cylinder is defining at what radius is the tool going to be perfect, and then it's going to gouge at the other spots if the geometry isn't perfect. Hopefully that helps. At least play around with it. If we need to dive deeper, reach out to some of us and we'll see if we can't put a video together to explain that concept. But I wanted to make sure that everybody's aware of that. Feel free to post some questions if you want me to be a little more detailed at the end of the webinar. And again, sorry to keep interrupting you there, Wayne.
Yeah, no problem. This is good information. Even with the heights, we can also put an offset so it drops down below. But again, as Al had mentioned, you got to make sure that your geometry is exactly the way it would be as the tool would come in to be able to cut that. Right? So you can add an offset. You can do everything you can with the 2D adaptive, but it's going to wrap it around that geometry. All right, and we have also the 2D contour. And I want to show you the 2D contour in this part. Actually, before we do that, I'm going to jump in and do this for the 2D contour, but I want to show you another thing. Somebody had asked earlier, okay, if I want that to go on all these different positions, we'd have to do another pattern. You don't. You can just simply drag it up into the pattern we did for the holes, and now it's going to be included in that same pattern. And now you'll be able to do the drills, then the holes, or the drill, tool change hole, or tool change pocket, and so forth. But the same toolpath will work whether you're doing 2D pocket or 2D adaptive or 2D contour to clean it up. Okay, but you can just drag it into the pattern, and the pattern kicks in, and you'll be able to do that rotary axis work. So the next thing I want to do is a contour, and I want to work my way around this outer edge with the contour. So I'm going to choose 2D contour. Okay, the same tool will work. In my geometry, I'm going to choose that wrap toolpath. Okay, for my wrap cylinder, we're going to do the inside. And then for my contour geometry, I'm going to select this edge right here. It selects that edge. I think the tool's going to start in this way. So I want to make sure I add some tangential extension distance because of where I selected the geometry as well. Okay, so let's say we add a 1/2 inch into there. Okay, I'm going to leave it like that. I think we should be okay. I'm going to say okay, and we'll get a contour that wraps around the front. I think I want to do that tangential different on the other side. You see how it's going in? So actually, Al, it's a good question while you're here. If I edit this, I'm going to go into my geometry. I'm going to leave this at 0. Is there a good way for me to change where I want that to start? Could I start it at this corner and ramp in here?
The best way is to use the entry point as on the linking tab. There's an entry point definition. To be honest, it's a live question. I'm not sure how well it's going to influence the 4-axis. And maybe I'll describe what entry point does at this point, though. Many people don't understand. There's 2 options there, pre-draw location and entry position. Pre-draw location is going to say there's a hole here. The toolpath has to start at the point I selected. Entry point is simply guidance. Start as close to this point as you can, so that does or does not need to be along your chain. It's simply saying, hey, I want to start close to here. I want to start looking at the front of my door. I want the toolpath to be on the front side of the part. You can select any geometry, does or does not need to be on the chain you're machining. Let's see how well it affects the wrap toolpath, though. Yes, it's around the corner a little bit. Probably going to need some more work on that, but that's the way you would do it.
Thank you, Al.
While I'm unmuted, Curtis is asking about where it is in HSM Works. There's a couple questions in regards to HSM Works. It will be part of the first paid tier of HSM Works. It's not there now. We're targeting our April release. I got to be careful giving dates, but we're trying to have it done in the April timeframe to get this moved over to HSM Works.
Awesome. Just a quick thing as I was looking at this earlier, one thing I was able to do, and if it's helpful, I just added that extension distance and then a separate one, and I just left this at 0. So when it comes out of the material, it's in the center of the hole there. At least in this setup for this toolpath, it works well. So there's always a solution. You can always find a way to get the toolpath to work the way you want it to. All right, so that's wrapping the contour. It's going around that wrap geometry we made. But when we post out the code, so I'm posting with that A-axis, and there's our drills. We got our pattern for our drills. Rotates around, and you see we get X, Z, and A-axis rotation here. So that's using the Haas A-axis post, as Al had mentioned. There may be some edits needed for that to be able to work for you. So as he had mentioned, our forums are a great place to go. If I bring up our forums. So if you go to our main site, there's a link here, and I can show you the main site. Go to the link to our Inventor HSM and HSM Works CAM forum. We have our expert elites in here. They answer questions. They're very active on answering questions. There's a lot of information you can find if you search in here, especially working with Rotary Access. We have our Autodesk Knowledge Network, another great resource to go to. And you'll find a plethora of information, links, places where you can find tutorials to work with. A really good resource to work with Autodesk Knowledge Network. And again, as I had mentioned, you can go to our main site. There's links in here. You can find a lot of information, especially when you're learning and you're new. Our Learning tab here will bring you to tutorials. We have our forum. You can click the link to our forum, which will bring you into that same page. Weekly webinars. We do have an upcoming webinar in 2 weeks. Carl Bass is going to walk through a couple of his projects that he used HSM on, and our team's going to be, it was going to be live, and that's on the 20th. It's going to be great to see some of the projects he works on in his shop.
Hey, Wayne, quick question. Who exactly is Carl Bass?
Carl Bass is the CEO of Autodesk. He is a maker.
Oh.
He's awesome. He loves our CAM. He loves working with machinery. He's got his own shop. I know Al and Tim on our team work with him a lot. He's got a lot of projects going, heavily involved in manufacturing and in CAM. And so,
hey Wayne, if you're done showing your screen, I know this is sort of off script, but I'm continuing to see a couple questions about this concept I mentioned of the wrap cylinder. So I created a quick parametric sketch to show it.
Oh, perfect. Yeah.
If everybody's interested, we can go ahead and show my screen, and I will. You're seeing my screen?
Oh, I can see it, Al. Looks great.
Okay. So I drew a quick sketch of a part here. It's a sort of a typical view of a 4-axis part. What I'm showing is the geometry on the side, so that would be parallel to the tool. I've modeled the way most wrap features work in CAD, or the way generally you'd model your part in CAD, where that edge is going through the center of the part. And that sounds like it'd be the right thing to do. It's most often how it's modeled. But the reality is you then have a tool that's coming over to cut that edge. And that tool, the center of that tool, is also going through the center of the part. That's by definition the only thing you can do, because you've only got the 4-axis to rotate, not 5. So what that leaves you with is this triangular sliver of material that's a result of this offset from the radius of the cutter. Hopefully that's making sense. So we're seeing the cutter kind of coming around, but it's not able to machine that full part. So what the wrap cylinder is doing is saying that edge I selected, whether it's the bottom edge or top edge, is where the cutter is going to be perfectly following the geometry. So if you select the top, then it's going to perfectly follow at the top and gouge the part. If you select the bottom, it's going to perfectly follow at the bottom and leave material at the top. Or you can use that offset and find some balance somewhere in the middle where it's gouging a bit at the bottom and leaving a bit of material at the top. Of course, the other option is to become a CAD wizard. I mentioned at the beginning of the webinar, you can't really be a CAM person without knowing how to strong-arm the CAD system to get what you want. So obviously the other option would be to model the part exactly how it's supposed to be, but we gave some functionality there in the CAD environment to find the compromise that works best for your part. So hopefully this little demonstration shows what the issue is. It's incidentally highlights what the issue was of using a swarf toolpath and locking it to 4-axis. That's kind of the same reason that starts to fall down and give you some weird noise. All right, I will go ahead and we can switch back to you, Wayne, but looks like some people found that very helpful.
I think it's great for clarity. Thanks, Al. All right, can you guys see my screen?
Yep, we see your screen.
Awesome, thanks.
Good. And Wayne, it might be a good idea just to prompt everyone to subscribe right now to this. Guys, we release these videos, and when you subscribe to our YouTube channel, the real benefit is that you're going to get an alert when we upload a new tip, new trick, whatever it might be, and that's going to be delivered to you via YouTube. So feel free to subscribe. Tell us about your inputs on what the content is that you watched in the comment section down below. Love seeing those.
Yep, so that's where you can find those. And there's also links to our upcoming webinars if you go to our main site. Again, I'm going to go back here again because I kind of breezed through really quick. So to see upcoming events, you can go to our weekly webinars page, and it'll give you a list of our upcoming events of what we're doing. I think we have to update this, but it will be updated really soon, and you can see what the upcoming events will be for the next few months. Tips, we upload tips every Friday. You'll get a new tip. So this is a great launching place. A great place to start is our cam.autodesk.com with a lot of links to our videos. And again, check out Lars's videos in here too. So look for Lars Christensen. He does a lot of great videos for learning and working with the part. Here's Lars here. And subscribe to his channel because he's got a plethora of information on his channel where you can learn and get started in working with toolpaths and design in CAD.
Perfect. Well, Wayne, Al, thank you so much, everybody. We really appreciate the attendance. If these are beneficial to you at all, please feel free to tell a friend about these Friday Hangouts. We also have Wednesday Hangouts for those just getting started with the platform. And again, thank you so much, Wayne and Al. You guys are really busy. So we really appreciate you guys taking time out of your day to help out the community, because that's what this is all really about, is just that HSM community. So have a great weekend, everybody, and thanks for joining. We'll see you next week.